Hey everyone, my name is Nangakun and this is the presentation video for the alternative assessment with the title Portfolio on Temporal Processing Speech Segmentation and Music Generation Task, which is the assignment 2 and 3 for the course Multimedia Data Processing with and from section 2. Alright, so first will be the assignment 2. This is a good assignment that focuses on the speech segmentation task or the experiment. We are given two sets of speech data, which each set consists of 10 speech data. The speech data sets given for our group are set A and set G, which consists of 20 sound patterns of the connected digit from male speakers to the female speakers. The main objective of this assignment are to read speech data and identify its feature in the time domain, and utilize the time domain features for speech segmentation tasks and communicate experimental results in an oral presentation. So the main task will require us to understand the initial algorithm given and identify the existing issues and problems of the algorithm to improve the algorithms. The improved algorithm should produce a more satisfying result in the sound segmentation according to the patterns of the given speech data. So this will be the coding for the algorithm. This is the flow chart of the benchmark solution, and this will be the result of the algorithm one based on the benchmark solution. So from this graph, we can see that the protocol will contain a lot of unnecessary lines, segmentation lines, or insertion lines. The algorithm did not detect the endpoints of the signal from the coding. So the unnecessary segmentation lines will be here. And from the coding, as shown in the highlighted area, the coding also did not detect the endpoint of the sound. So our proposed solution is to detect the increasing and decreasing part of the sound and store all the segmentation points into an array, and then find unnecessary segmentation line and delete it. So it will not produce very many unnecessary segmentation line. And lastly, it will draw the segmentation point. And this will be the flow chart of the proposed solution. And this is the coding of the proposed solution, and we added two coding here in the highlighted area, right? And this will be the result of the algorithm one based on the proposed solution. So from this figure, we can call that the experimental result carried toward the speech dataset based on the proposed solution will detect the increasing and decreasing part of the audio and remove the extra segmentation lines detected to achieve a low insertion rate. So by comparing the result of the benchmark solution as shown in the figure 3 and this proposed solution in figure 7, we can see that the proposed solution will not produce unnecessary segmentation lines, and the segmentation line will be drawn a start and endpoint for each audio part and produce a more satisfying result. Alright, so this will be the comparison of the benchmark of the proposed solution. So the proposed solution will have a higher mesh rate compared to the benchmark solution, and it will also have a lower omission rate and also the insertion rate, which make it a better algorithm to test the data. So from the graph shown in the figures before, the overall observation of the graph after using the first algorithm compared to the benchmark algorithm produces a result with an increment of mesh rate and decreasing of omission and insertion rate. So we conclude that the proposed algorithm has better segmentation performance than the benchmark algorithm. Next will be the assignment 3. So this assignment is an individual assignment which focuses on the scripting to produce music. So an example will be given to show the basic coding to produce a simple music. The main objective of this assignment is to create the music sound effect from simple sound manipulating through the coding from basic fundamental waves or a combination of existing music waves. The musical frequency will be written according to the frequency of the piano to produce a different sound. So to complete this assignment, a theme is needed, which can be found on the back. So the theme I chose is the canon, which is a pure music. So this will be approach taught in the classes, and this will be the frequency of the piano key that I will use to display each sound of the theme that I choose. All right. So next, This one is the coding part for my music generation task. This will be the frequency for each key that I want to use, and it has the respectively duration of each key. And I will loop the key and frequency inside this loop, and using the knot to show the sound. And it will pause after 0.22 seconds and display the sound of the music. So basically, it will be the coding of the part, and this will be the source that I use to generate the music for the canon, which I use. Is the piano version. So, in conclusion, the generation of the music using the melody is possible by using the correct frequency for each piano key. So, a good adjustment of the frequency and duration for each music clip need to be carried out carefully to produce a nice music, which is canon in this project. The theme of the music can be achieved easily by looking at the sheet music and putting the corresponding frequency for each music clip and adjusting the duration of the music clip. So next I will show the demo of my music. So now I will play the music that I made. So that's all for this presentation.